In this second tutorial, we're going to discuss the second tab on the spreadsheet called Images of CRM. Notice before we move to that tab that we have solved on this first tab the equation for a product with a 4-year lifespan spending 17% of revenue in R&D trying to achieve a 10% CAGR. It is solved at 6.99. That's the CRM required. Now let's look at the images of the data that we have basically generated on. By going to this Images of CRM, there are 6 charts in total on this second tab. And we bring over from the first tab essentially the business goals, the 17% spend rate, the 10% CAGR, the 4-year product lifespan, and 6.99 as being the multiple that was achieved. So let's look at this graph in the middle first of all. This shows the growth in revenue. It's showing an area chart looking at both the base business as well as new business. And it's showing us that the base business, which starts at 100 here, shown in red, will decline such that because it's a 4-year lifespan product, approximately 90% of that revenue will be gone within 4 years. Then on top of that, as an area chart, we are showing the revenue that comes from each one of the annual crops of products, where this blue section is the first crop of products, the second, and how they overlap with one another. That first crop of products gets introduced. It has, for the most part, gone after 6 or 7 years. Second crop of product lasts a little bit longer, etc. As we move over to the right-hand side, notice that each one of these sections gets slightly thicker. That is because each year, because our revenue has grown at 10% and that we're spending 17% of that revenue each year on R&D, we are growing and we're spending more money on R&D, so the crops of products produce slightly more revenue, i.e. they are getting slightly wider or thicker. This top line, which is the total revenue that is achieved from each one of these crops, from the accumulation of those crops of products, is growing at precisely 10% CAGR each year, and by the end of 20 years has grown to 673 million of revenue, which represents a 10% CAGR from year 1 based on starting at 100. If we look at some of the other charts, the one on the left shows exactly the same data as this one, but it shows it minus the base business. So you will see what happens to those new crops of products. Probably one of the more interesting graphics is this one, which says this is the natural fall-off rate of the modeled business scenario. And where do we get that data from? Well, on this chart up here, after the base business has become fully declined, in this case that's after about 6 or 7 years, the red is all gone, I can look at any one of these sections. Let's take this blue section here and say if I didn't produce any of the crops of products beyond that I just stopped at that blue section, what way would the revenue decline? And it's clear it would go from here down a little bit in the first year, down more by the second year, third, fourth year, etc. So that natural fall-off rate of the business scenario that we're modeling would have a defined fall-off rate. And I can calculate what that fall-off rate is, and it is shown down here. It says 5.1% of the revenue would be gone at the end of the first year, 35.5% cumulatively gone by the end of the second year, etc., such that after really 4 years, almost 90% of it is gone, not quite, but then the rest of it is gone sometime after that. We will show later on that natural decline rate is what we use to plug in to the base business decline rate. That's how we actually calculate the base business decline rate. Let's move over to the other 2 graphs here. This shows us essentially the S-curve for products with a 4-year lifespan. It tells us for any one of these products, if I was to look at that product crop in isolation, from the time I introduced it, how much did the revenue go up by, and of the cumulative revenue that we achieved, how much of it would be achieved in year 1, 2, 3, 4, etc. So that's 11.5%, 42.1%. And below that, all the way up, by the way, to the 100% cumulative revenue. Below that, we show the shape of annualized revenue. In other words, for each one of those years, what percentage of the revenue was achieved. After year 1, that would be 11.5. After year 2, that's just 30.5. Adding the 11.5 to the 30.5 would give us the cumulative 42.1, etc. But you can see that the revenue would go up and then it would start to decline, and for the most part by year 6 or 7 there's no further revenue, but we have achieved 90% of that revenue after year 4 on a cumulative basis, which is the definition of our lifespan. So now let's go back and see what those images would look like were we to change parameters in our calculator spreadsheet here. So I'm going to change that now to products with a 16-year lifespan, holding the business goals exactly the same, 17% and 10%. And because it's now not equal to the 12.29 I need to solve, hit solver, solve, let it do its solution here. It works through that and should come back with the 12.29 as the answer, which it does. And now let's immediately move to the images and see what it now looks like. And immediately you'll see it changes. Let's drag it back and look a little bit here. First of all, the area chart of total business. Well, first thing that you notice is that the base business takes a lot longer to fall off. And in fact, that base business, which is the area shown in red, actually grows a little bit for a while before it starts to decline. But by year 16, 90% or approximately 90% of that revenue is gone. Each one of the new crops of products now is much more stretched out than what we saw with 4-year products, because they grow much slower and they decline much slower. But notice that from our 100 million of starting revenue, this has also grown at exactly 10%, such that by the end of year 20, we have reached the same 673 million of cumulative revenue. But the decline rate for any one of these segments here, because they're 16-year products, would be much slower than the 4-year one. And we can see that when we make the calculation down here as to how are those segments declining. Remember, we've got to look at those segments sometime after the base business has been fully depleted to see what the natural decline rate of one of these segments is, and that decline rate is shown over here. So what actually happens is the business will grow for a short while, even if we stopped further investment in R&D, because the products that are in the base business have long lifespans. But then obviously it would start to decline, such that by year 16 here, approximately 90%, it's actually 84.3% of that has declined. That is what we actually use to calculate the base business decline rate. So the base business decline that you're showing here is exactly per this equation. And if I go back to my CRRM calculator spreadsheet over here, where we're looking at the base business decline rate, if I click on this cell here that says, well, how much has this base business declined? That says that 8.3% is equal to cell AB146. Let's take a look at what AB146 is. Come down the spreadsheet and go over to AB146. AB146 starts there's that 8.3. What this is calculating is what are the crop of products up to year 25. If I just look at those and no further crops beyond that, and if I was to essentially ignore all crops that were produced after year 25, how would that business have declined? I'm doing that, I'm calculating that by simply summing lots of the cells above that show the annual revenue, and you can see that I'm summing the same cells as I go across here, and it calculates exactly what that decline rate is. It then basically takes that decline rate and feeds that directly back to being the base business decline rate. In other words, whatever the natural decline rate of the overall business that we're modeling is, that is fed back as the decline rate of the base business. And once that's done as part of this solve here, a unique value of CRRM emerges, and that unique value is 12.29. That happens to be exactly the same as our equation, but remember, it was this iterative solve that came first before our equation.